Yo, what is good, YouTube? It is your boy here, Smat Sill, back at it again with another video. Now, in this video, we are going to be learning about calculus. Let's go. All right, so we are now continuing from the previous section, which was just learning about the basics of integrals. And now we are moving on to integration by parts, which is I guess it's a technique. So I believe there are two main methods of completing an integration. The first would be the U substitution method, and this is the second one. This is the integration by parts method. So if integration by substitution fails, it may be possible to use a double substitution, better known as integration by parts. So if I'm not wrong, this is derived from the derivation of a product of two functions, and you just kind of like move it around here. So let's see. So we have the derivative of a function. Let's say it's h of x, and h of x is equal to u of x times v of x, and the derivative of that h of x, the derivative of that function, would be equal to u v prime plus v u prime, or I like to do this as u prime v plus u v prime, or whatever. So they just move the derivation to the right, and they move this little buddy over here to the left. I guess you can make another formula where the one on the left would be v of x times u prime of x, and this one will be on the right, but I guess this is the more frequently used one. So by integrating both sides of this equation, we get this, and yeah, this is the basic general equation. Now, the thing we must understand here is the indefinite integral version of this formula, right? So contrary to popular belief, or contrary to Smat Sill's previous former belief, you actually have to integrate this part as well. You have to integrate it from a to b, which doesn't seem that obvious actually, because you think you just leave it and you just integrate these ones, but no, you actually have to integrate that one as well from a to b. I guess that's the only thing we need to take note of here. This is it's the same thing without the of x, right? And this is the visual representation. Let's look at the integral of x cos x dx. So first things first, we want to have a u and we want to have a dv. So we need to pick a u, we need to pick a dv. So we wish to write x cos x dx as u dv. One possibility is to let u is equal to x and dv is equal to cos x dx, then du is equal to dx, and v equals the integral of cos x dx, which is in x. We're going to omit the arbitrary constant at this stage. So we need to omit the plus c, the arbitrary meaning arbitrary number. You know, I was always confused by the word arbitrary. What does that mean? I'm not really sure until to this day, I don't know. Arbitrary or a mutually defined, but I'm not sure. I don't really think that. In my belief, I think arbitrary means what do you call it, bro? Wait, hold on, bro. I don't have 3 subs, bro. If I think arbitrary means all right, so let's look over here. I think arbitrary means like an abstract number, but abstract's not because they sound the same. So I tend to relate one to another, one with the other. But that's not what it actually means. Arbitrary, I'm not sure. I'll have to get back to that in a moment. But here's a summary of this double substitution in the convenient format. Hold on, my food might be here.